Okay, in this video we're going to look at resistors in series and in parallel connection. So let's start off with resistors when they are connected in series. So we have a battery of V and three resistors R1 and R2 and R3. So I'm sure you remember that to find the total resistance of resistance series is R1 plus R2 plus R3. Okay, but in A level you also need to know how to derive that equation, how to get that equation. All right, so let's look at potential difference. So in order to derive that equation, we'll start off with the potential difference equal to the EMF. Okay, it's like Kirchhoff's second law. So V equals to V1 plus V2 plus V3, and we need to change this into IR. So IR equals IR1 plus IR2 plus IR3 because it's in series. The I, they are all the same here. Okay, so current passing through all the resistors, they are the same, and therefore we can take the I out of the equation and it become R1 plus R2 plus R3. Okay, simple enough. Then we look at parallel connection. Same thing here, parallel connection, you also need to know how to derive the equation, which is 1 over R total equals to 1 over R1 plus 1 over R2. Alright, so let's start off with the Kirchhoff first law. So current coming out from the battery, it branched out into two current due to the two resistors in parallel, I1 and I2. So I equals to I1 plus I2, and we change that into V over R. So we have V over R, the EMF of the battery, equals to V over R1 plus V over R2. So remember, things that are connected in parallel in a circuit, they basically have the same potential difference. Okay, so V across the R1 and V across the R2, they are the same because these 2 points here, they have the same potential difference. Therefore, when we take the V out, you will get 1 over R equal to 1 over R1 plus 1 over R2. Okay, remember to find, don't forget to find R, you still have to inverse the whole, thing here to get the R, yeah? Okay, so let's move on to the example. So we have a circuit that has a combination of parallel and series connection, and let's find out the quantities of current and potential difference that is asked at the top here, I1, I2, V1 and V2. So given that the EMF of the battery is 6 volts and the resistance are all given, so let's start with that. To find the resistance, the total resistance, we have 2 plus 1 over 12 plus 1 over 4. So this is the parallel connection. Okay, so always identify the parallel and series connection. Okay, so sometimes they are nested inside each other, so you're going to identify them clearly and find them one by one before you add them up in a series. All right, so we get 5 ohm, so altogether is 2 plus 5 ohm. That's right, 2 plus 3 ohm. So total is 5 ohm. Okay, therefore we can figure out that the current, the overall current that comes out from the battery is 6 over 5, so it's 1.2 ampere. And to find V1 is here. We can use the current that we have found just now, 6 over 5 or 1.2. This is the current multiplied by the resistance of it, so you get 2.4. So once you get 2.4 across the V1, across the R1, then automatically you can know that V2 is 6 minus 2.4, okay, from the Kirchhoff second law, conservation of energy. Or you can use 1.2, the current just now, that passed through the combined resistance of the two parallel resistors. Then you get 3.6, so you get the same answer. In circuit, you always have multiple ways of finding a quantity, depends on which one is faster and which one is easier. Okay, therefore after that we can use we can find I1, the particular one that passed through the 12 ohm. So that's the 3.6, the PD across the 12 ohm, 3.6 divided by 12 ohm, so V over R is 0.3. And because of that, we can straight away use 1.2 minus 0.3, that will give us the 0.9. Alternatively, you can use 3.6 PD across the 4 ohm divided by the 4. Okay, so next example, we're going to look at a case where most students get confused sometimes. Okay, it has a battery and it has 4 resistors here. So the mistake here is always making the wrong choice of connection, as in series or parallel combination. Okay, so how to identify the series and parallel connection? At first it looks very confusing, but let me teach you one technique here. So first of all, you look at the current. So when this current reaches the junction here, so what happened is it branch out into two. Let's say I1 and I2. And let's identify the road of I1. So it's going to go through all the way here. There's no junction, so it's still I1. There's no junction still, so it's still I1. And then it passed through the 10 ohm, and then it arrived at this junction on the opposite side. So all throughout here is I1, and I2 is the one that passed through the 15 ohm all the way down to the one on the opposite side. So when you see current branch out and join back again, so these two resistor that it passed through, the 15 ohm and the 10 ohm, they must be the parallel ones. Okay, these two must be the parallel one, because the DR current is the one that branch out and join back. Okay, that's how you identify parallel connection. So this is the parallel. And then when they come back here, it becomes the I again. Okay, I equals I1 plus I2. So you come back here, pass through the 4 ohm, pass through the 2 ohm. So which means that the parallel connection just now, you find the resistance of that. That must be the series connection. That must be in series with the 4 ohm and in series with the 2 ohm. So overall, we have total resistance equals to 4 plus 2, that's the 2 resistance series, plus the inverse of the parallel resistors. The inverse of the parallel resistors. So afterwards, you can find the value of that, and using the total resistance and the 24 volts here, you can find the current. Okay, so we go for the next examples. So next examples are combinations of resistors. You have it on your handout, so I want you to write down the solution clearly and send back to me as an assignment. Okay.